All right, so here we are with rational exponents, nth roots, part 2. So let's keep moving. All right, next I want you to use the definition of rational exponents, which we just talked about, and the properties of exponents to write each expression as a base with every single rational exponent, then use a calculator to evaluate each expression, round your answer to 2 decimal places. Okay, so here's an example for you, right? If I have the cube root of 4 squared, I can rewrite that as 4 to the 1/3 squared, which becomes 4 to the 2/3. Now, I will point out, if you go right from this step to this step, that's fine. You don't have to do this intermediary step. The intermediary step, though, is important in understanding why this does become this. The other thing that we want to make sure we understand, so ultimately, we want to use the definition of rational exponents and the properties of exponents to write each expression as a base with a single rational exponent. So that's what this is, okay? So I want you to go from this term to this, and then type this into your calculator and round to 2 decimal places. So I want you to try to do that with A, B, C, D, E, and F. And again, you can look at the example at the top. So I want you to pause the video, try those on your own or work with a partner. Unpause when you're ready to check your work. Okay, so again, the intermediary step, it's up to you if you did that or not. Ultimately here for A, this is the square root of 5 to the 3rd, so that's 5 to the 1/2 to the 3rd, which is 5 to the 3/2. So this is the important part, that we can go from this to 5 to the 3/2. If I type that into my calculator, it's approximately 11.18. For the 4th root of 4 squared, that becomes 4 to the 2/4, which is the same as 4 to the 1/2, which is the square root of 4. So that's why that became 2. The cube root of 9 squared is 9 to the 1/3 to the 2nd power, which is 9 to the 2/3. If I type this into my calculator, it's approximately 4.33. The 5th root of 10 to the 4th is 10 to the 1/5 to the 4th power. This is 10 to the 4/5. If I type this into my calculator, it's approximately 6.31. The square root of 15 to the 3rd, it's 15 to the 1/2 to the 3rd power, which is 15 to the 3/2, which is approximately 58.09. The cube root of 27 to the 4th is 27 to the 1/3 to the 4th power, which is 27 to the 4/3, which is 81. Last thing I want to emphasize is for both A and E, again, just remembering that the square root, anytime we have a square root, which is a root where we don't have an index written here, this little number is called the index. So here it's an index of 4, here it's an index of 3, here it's an index of 3, here it's an index of 5. So anytime we have nothing written there, that implies that it is square root, which tells us that the index is actually 2. We just use square roots so often that we don't write the index. Okay, next thing I want you to, again, do a little work on your own because hopefully you're catching on. Now we're going to just do the opposite of what we did on the previous slide. So here we're going to start with a number raised to a rational exponent, and then we're going to convert that into a radical raised to an exponent. Then again, we are going to just type that into our calculator to make sure we understand how to type that into our calculator. So here's your example. I want you to pause the video, and then I want you to do A, B, C, D, E, and F, either on your own or with a partner. Unpause when you are ready to check. All right, so here I've gone through this. Again, if you didn't do the intermediary step, that's fine, as long as you have the second 2 things that I have, or the last 2 things, I guess I should say. So 8 to the 2/3 is the same as 8 to the 1/3 squared. So we need to make sure we can write that as the cube root of 8 squared. Again, that is the important part. So if I go right from the original to the green, that's okay. If I type this into my calculator, that's 4, because the cube root of 8 is 2, 2 squared is 4. All right, here I have 6 to the 5/2, that's 6 to the 1/2 to the 5th. Again, the important part here is what's in black, so that is the square root of 6 to the 5th, which approximately is 88.18. 12 to the 3/4 is 12 to the 1/4 to the 3rd, which is the fourth root of 12 to the third. So the blue is the important part, and then the purple, which is approximately 6.45. For D, we have 10 to the 3 halves, which is 10 to the 1 half to the third, or again, the red is the important part here, the square root of 10 to the third. This is approximately 31.62. For E, 16 to the 3 halves is 16 to the 1 half to the third, which is the important part here in purple, the square root of 16 to the third, which is 64. F is 20 to the 6/5, so we have 20 to the 1/5 to the 6th. This becomes the fifth root of 20 to the 6th, which is approximately 36.41. Nice work. Any questions? Okay, you guys are being kind of quiet today. All right. So what this slide is telling us is something that we already know for the most part. So don't let this overwhelm you. If we have an even integer as an index, so think about what that means. That means like square root, right? We've dealt a lot with square roots so far this year. So if I take a square root of both sides of an equation, remember I always need to do plus or minus. That's what this is telling us here. If I have an odd index root, I don't do the plus or minus. I just leave it as if it was positive to begin with, it's positive. If it's negative to begin with, then it's negative. So that is all this is really telling us. We also know that if I have an even integer and the original number was negative, there's going to be an imaginary value. So that means no real roots, right? Imaginary are not real numbers. So that's what this is telling us. Okay, we're going to use this to help us solve equations. All right, so let's look at this. I'm going to start with A. So we have 4x to the 5th equals 128. What should we do first? Well, anytime we're solving an equation, we want to get the variable by itself first. So I'm going to divide both sides by 4. Now I end up with, I'm going to write over here, x to the 5th equals 128. If I don't, I'm sorry, x to the 5th equals 32, right? Because I divided by 4, and 128 divided by 4 is 32. Good, I did my math correctly. Now, how do I get rid of an exponent of 5? Well, if it was an exponent of 2, I would do a square root. If it's an exponent of 3, I would do a cube root. Since it's an exponent of 5, I'm going to do a fifth root. Now, remember that that is the same as to the 1/5 power. Doesn't matter how you write it. Now we also need to think about, is 5 an even number or an odd number? Well, 5 is odd, so I know I don't need plus or minus. So the left-hand side of the equation is just going to become x. I'm going to go to my calculator if I don't know this, and I'm either going to type in 32 to the 1/5, which is 2, or I'm going to do math, and I want the fifth root. So remember, we actually have to type in 5 math. I'm going to go down to the fifth root, or to the x root, sorry. Oops, going a little too quickly, my bad. Let's do that. And then we want 32, and that's 2 as well. So we don't have to do that twice. Either one of those work. So I get x equals 2. That's my answer. For B, well, what are we going to do first here? Well, there's nothing to add, subtract, multiply, or divide by because the exponent, which is 4, is on the entire quantity. So the first thing I'm going to do is I'm actually going to get rid of that exponent. So I'm just going to rewrite this. So I have x to the minus 3 to the 4th equals 21. And now we are going to do a fourth root of both sides. The fourth root of 21 is not a nice number. It's an irrational number, I should say. So I do fourth root of 21. So since it's an irrational number, I'm not going to do anything with that. I'm just going to leave it as fourth root of 21. But what I do have to pay attention to is this was an even number. And if I have an even index, I need a plus or minus. So I have x minus 3 equals plus or minus the fourth root of 21. 4. What's my last step? Excellent. I'm going to add 3 to both sides. Glad to see you guys are paying attention. So I end up with x equals 3 plus or minus the fourth root of 21. All right, I want you to try this on your own. So I want you to solve each equation. Then you can, so first write it as an exact value and then type it into your calculator and round to 2 decimal places. Pause the video, try this, unpause when you're ready to check. Okay, so for 13, the first thing I did was I wanted to get the variable with the exponent by itself, so I divided both sides by 8. So then 64 divided by 8 is 8. So my result after the red was the green, and I was left with x to the third equals 8. But now I need to get rid of the 3 exponent, so I did the cube root of both sides, and the cube root of 8 is 2. I did that on my calculator if you don't know that by head, in your head. Number 14, since I had 1/2 x to the fifth equals 512, to get rid of the 1/2, instead of dividing, I multiplied both sides by 2. So then I went from the green to the blue, which was x to the fifth equals 1024. Now I had to get rid of the 5 exponents, so I did the fifth root of both sides, and I end up with x equals 4. Again, I did this in my calculator, if you don't know the fifth root of 1024 in your head. Number 15. So here there was nothing to do in terms of multiplying or dividing to start with, since the entire quantity was raised to the 4th power. So the very first thing I do is I do the 4th root of both sides. Since this is an even index root, now I need to do the plus or minus. So notice on problem 13 and problem 14, we had odd index roots, so odd numbers. Not that they were strange. That's not what I mean by odd. So I need plus or minus. So the 4th root of 16 is 2. So I have x plus 5 equals plus or minus 2. Then I can subtract 5. X equals negative 5 plus or minus 2. And since these are both integers, I can actually do this arithmetic. Negative 5 plus 2 is negative 3, and negative 5 minus 2 is negative 7. For 16, we have x minus 2 to the third. So I'm going to do similar to 15. There's nothing to multiply or divide by right away. I need to do the cube root. Since it's the cube root of a negative, I am not going to get imaginary numbers. It's only if I have an even index with a negative underneath the root. That's when I have to do the I. But since it's an odd index, I don't need to do that. It just stays negative. So this becomes x minus 2 equals the cube root of negative 14. Then I just add 2 to this side. We could leave our answer like this, but the problem here was saying to type into our calculator if appropriate. So I did 2 plus the cube root of negative 14. And so if you want to see that, that would be 2 plus math, fourth choice down, cube root of negative 14. I hit enter, and that's how I got the negative 0.41. So I wrote negative 0.041. Okay, so I just want to sum up. One of the biggest things you should hopefully get from this lesson, if you get nothing else, is just the ability to take a base raised to a rational exponent, which means a fraction, and convert it to a root and an exponent. Or take a root and an exponent and convert it to a base raised to a rational exponent. That is one of the key takeaways that you want to have. Everything else we did is also very important. Being able to solve equations and simplify and combine like terms, multiply bases, have exponents raised to exponents. But this is the big new concept of taking a rational exponent and converting it to a root and an exponent, or going back the other way. Your homework is 5.1, day 1.